Most people who are afraid of flying hate seeing news about aviation accidents and incidents. But now imagine that you're seeing live coverage on an ongoing incident as it's happening, but you are sitting inside of the aircraft it's happening to. That's exactly what happened to the passengers on board JetBlue Flight 292, and I will tell you the entire story, so stay tuned. A huge thank you to Blinkist for sponsoring this video. The story about Jet2 Flight 292 started on the 21st of September 2005, and the aircraft involved was a 3-year-old Airbus A320. The aircraft started its stay in JFK Airport in New York, and before the first flight, the engineers had done some light maintenance work to the nose gear, where they had replaced some proximity sensors. These are basically sensors that feels if the aircraft is in the air or on the ground. Once the maintenance job was complete, the aircraft was flown over from JFK over towards Bob Hope Airport in Burbank on the west coast of the United States. And there it was supposed to do a quick crew change, and the aircraft was then supposed to fly back towards JFK later in the afternoon. For the return flight, there was 140 passengers scheduled, 4 cabin crew members and 2 pilots. Now, the 2 pilots were both very experienced. The captain was a 47-year-old with 10,800 hours and about 2,500 hours on the Airbus A320. He was assisted by a 37-year-old first officer who had around 5,700 hours and just under 1,300 hours on type. The weather in Burbank was beautiful, with only some high clouds, good visibility, light winds, and it was decided that the first officer was going to be pilot flying for the return flight to New York. So he started setting up the cockpit, started programming the flight management computer, while the captain did the walk around outside. Now, during the walk around, the captain didn't notice anything suspicious, so he got back into the cockpit, and together the crew finished up the pre-flight preparation, the checklist, and started preparing for the pushback. Before they could go though, they had to complete the fueling, and they had requested quite a lot of fuel, 14,750 kilos for their flight over to New York. But eventually the fueling was completed, the crew received the fuel receipt, and at the time 15:17 local time, the Airbus A320 started pushing back from the gate and started taxiing out for takeoff at runway 15 in Burbank. The first officer was pilot flying, initiated the takeoff roll, he set takeoff thrusts, the aircraft started accelerating down the runway, it got airborne, and once it achieved positive rate of climb, the first officer asked the captain to select gear up. Now here is where the problems are starting, because the captain reaches over and, according to his statement, tries to move the landing gear lever up, but it won't move up. Instead, he receives the first ECAM message, which is landing gear shock absorber fault, and then very quickly followed by nose wheel steering fault. Now, what has actually happened here is that 2 lugs on the upper support of the nose wheel shock absorber has completely sheared off, probably on an earlier flight. Now, the function of those 2 lugs is to keep the shock absorber from being able to rotate inside of the nose gear leg. And without those lugs, the nose gear has actually moved slightly out of position after takeoff. This was then felt by the landing gear control and interface unit, the LGICU, which stops the retraction of the landing gear. And the reason it's doing that is because there's just unlimited amount of room inside of the nose wheel well bay. And if the nose wheel is not in the correct position, then it might not have enough room to be retracted properly. So that's the reason for the first warning that was issued. And on top of that, another computer called the Braking and Steering Control Unit, the BSCU, has also noticed that something is off with the nose wheel, and it has deactivated the nose gear steering, and that was the reason for the second ECAM warning. Now, it was later found that it was actually the BSCU that was part of the reason that this problem happened in the first place. Because the BSCU had on previous flights been doing something called a self-test, which has happened anytime that the gear was selected down, the BSCU would start to move the nose wheel left and right a couple of times in order to just check that the nose wheel steering was working properly. The problem was that it was doing this as many as 57 times during the descent in towards the airport. And because on this aircraft the shock absorber had not been properly pressurized, it hadn't been serviced properly, this caused a bit of friction to build up in the upper support. And when the BSCU was doing all of these self-tests, it caused fatigue cracking in those lugs, which eventually broke them off. The pilots, of course, had no idea that this was going on. They only knew that they were facing a potentially very serious problem with their landing gear. So the captain got into contact with SOCOL Control. SOCOL gave them a clearance to climb to 14,000 feet and then handed them over to Los Angeles Control. Los Angeles Control then gave them vectors in like a box-like holding pattern over the Palmsdale Lancaster area at 14,000 feet. Now this problem didn't only stop them from retracting the gear, it also stopped them from engaging the autopilot and the autothrottle, which meant that the first officer was now hand-flying the aircraft with gear down at 14,000 feet, and he was also taking care of the radio communication, because as they were now holding, the captain started to get into contact with JetBlue management, both the dispatch and their technical department. JetBlue Maintenance did a remote diagnostic of the aircraft, and that diagnostic showed that there was a possibility that this might be an indicator fault. But together with the flight crew, they decided that the best thing to do is probably to fly over towards Long Beach Airport. In Long Beach, JetBlue has a major maintenance hub, and potentially come in and do a landing there to have a look at it. After they had decided to do this, the captain got into contact with the cabin crew and informed them about what was going on and about their plans to go over towards Long Beach. And it's at this point that the cabin crew informs him that the passengers are actually able to follow their own flight on the in-flight entertainment system, because the aircraft has an uplink that enables the passengers to watch TV. And of course, this has now been going on for a while, and because this is happening over the Los Angeles area, multiple TV stations have picked up that this aircraft is having a problem. So the passengers are actually watching themselves on news in real time, which is not something that I've ever heard of before this, and it's definitely not something that I would like to be part of myself. The aircraft now starts to descend in towards Long Beach, and the pilots have informed air traffic control that if they are able to do a successful landing, they won't be able to taxi off the runway because they're having this problem with the nose wheel steering. During the descent in towards Long Beach, the captain also asked the tower if it would be possible to do a low altitude flyby of the tower so that they can inspect the position of the nose gear prior to their actual landing. This is agreed to by air traffic control, and as the aircraft is entering the approach in towards Long Beach, a local traffic watch helicopter which is nearby is able to see them on approach and can tell them that yes, the nose gear is actually angled 90 degrees towards the direction of the aircraft. The pilots acknowledge this, but they continue the low approach and flyby of the tower anyway. And as they're doing the go around, the air traffic controllers in the tower can indeed verify that the nose gear seems to be twisted 90 degrees off its axis. The pilots now know that they're facing a much more serious problem than they initially thought. The captain issues a mayday call at this point, and then they request a climb to 6,000 feet to keep troubleshooting the issue. When they level off at 6,000 feet, they know that there are no ECAM actions for this particular problem, and there's no real guidance in their manuals either. However, there is guidance for something called landing with an unsafe landing gear. Now, this is not exactly the same as the pilots are experiencing, because they actually have all of the landing gear extended and they have green indication on their landing gear indicator, basically telling them that the landing gear is safe. But they also know that the nose wheel is 90 degrees towards the axis, and they're not sure that if they land with this problem, the landing gear will be able to take that amount of stress that it will be subjected to. It could potentially collapse, and in that case, they are theoretically in a situation with an unsafe landing gear. So that is how they're approaching this issue. Now, one thing that is playing in the pilot's favor here is the amount of fuel that they have on board. The Airbus A320 is a short to medium haul aircraft, which means that it has a reasonably small difference between the maximum takeoff weight and the maximum landing weight. And because of this, there's not really a need for a fuel dumping mechanism on an Airbus, just like it's not on the aircraft that I fly, the Boeing 737. This means that the only way for this aircraft to reduce its landing weight, and by that also reducing the potential stress on their nose gear, is to burn off fuel. And they have a lot of fuel on board. So this is what they're now starting to do. The aircraft is now once again receiving vectors, and this time they are in the area between Santa Catalina Island and Long Beach Harbor. And once again, the pilots have to discuss together with the company representatives what the best solution to this problem is. And the kind of things that they're talking about is, for example, is there any system reset that we can do that could potentially get the nose gear back into the centered position again? Also, What kind of fuel will give us the best aft center of gravity that will take away as much as possible the stress on the nose gear after landing? What kind of configuration should we be using during the landing, and how is the aircraft going to handle once we lower the nose gear? Are there any other checklists that we should be going through that is not immediately apparent to us? And also, how should we deal with the passengers? How should we brief them and the cabin crew, and what will we do after landing? What will a potential evacuation look like?
Prøv nyheten fra Nidar og Kims, Crunchos.
Hvordan skal verden takle klimakrisen midt i en energikrise? Se serien der 4 unge får utforske og utfordre Equinor sin omstillingsplan. Se hele serien nå.
Now, all of these kind of discussions and the way that this flight crew is discussing amongst themselves shows a fantastic use of threat and error management. Because this is exactly how we're supposed to deal with it. You are faced with some kind of problem, and then you have to kind of project how this problem is going to affect you in the future. That is the management part of threat and error management, and this is exactly what they're doing. This is actually a very good example of how time available decision making is supposed to look. Another thing that the pilot needs to decide at this point is where they are going to divert to. Initially, they were looking at Edwards Air Force Base, Miramar, but the captain decided that he would actually prefer to go to Los Angeles International Airport. And the reason for that is because the runway is slightly longer and they have a very wide runway as well. And he thought that if we are going to have problems with the directional control of the landing, it is better to have a wider runway, once again showing good situational awareness. In the back of the aircraft, the cabin crew has been briefed by the pilots about the problem they're facing. They have also been told to move passengers and hand luggage from the front of the aircraft towards the back in order to try to move the center of gravity a little bit more backward to once again get pressure off the nose wheel. They're also handing out blankets, pillows, they're explaining what's going on to the passengers, they're serving them with non-alcoholic drinks, and they're starting to prepare them for an emergency landing. And I have to say that the description of this in the final report shows excellent competency from the cabin crew. They're doing the job exactly the way that they're supposed to do. Really, really nice to see. Unfortunately, the passengers were still able to watch themselves on the news on their in-flight entertainment screens at this point. And one of those passengers, screenwriter Zach Dean, actually started to really contemplate his own mortality in this situation. And that eventually led up to him writing a script that became the movie Deadfall. Now, the cabin crew did eventually switch off the in-flight entertainment screens about 50 minutes prior to the approach into Los Angeles Airport. And what happened during that approach and the subsequent landing, I'm going to tell you all about after this short message from our sponsor. This video is sponsored by Blinkist, and I'm really happy that it is, because if you're like me, really curious, you want to learn new things all the time, but maybe you don't have enough time to do so, well then Blinkist is the perfect tool for you. They have more than 500 non-fictional titles in 27 different categories, and what they do is they take these books or podcasts and they distill them down to their absolute essentials, which they call blinks. This means that you'll be able to listen through or read through something that will take you hours to read through in only 15 to 20 minutes, which is perfect for your commute to work, for example. Now, I came here to Dubai and I was really interested in why there were so many successful entrepreneurs that was coming from here. So I just typed in Dubai into the Blinkist app and it came up with this Blinkist title, which was called Startup Rising by Christopher M. Schroeder. And it told me everything I needed to know about why there's so many successful startups here. Now, if this sounds interesting to you, then use the link here in the description below, which is blinkist.com/mentorpilot. That will give you a 7-day free trial. And if you like it, then you'll get a whopping 25% off the premium membership. So go and check it out now. Before they start the approach, the captain once again calls up the cabin crew and he informs them that there is a possibility that after landing, the nose gear might collapse. And if it does so, there's going to be an evacuation needed. But of course, with the nose gear collapsed, the aircraft is going to be at a very strange angle, with the nose very low and the back of the aircraft very high. So he tells them to not use the aft emergency exits if this happens, because it's a chance that the exit slides are not going to be long enough to actually even touch the ground below them. Once again, this shows exceptional threat and error management and situational awareness on behalf of the flight crew. As the aircraft leaves 6,000 feet and start descending down towards Los Angeles Airport, millions of people are watching this happening live. This means that there is a big possibility that the relatives and the friends of the people on board are also watching this. The cabin crew knows this, and they kind of step up away from the procedures for a short second, where they let all of the people on board take up their mobile phones and call their friends and families for a couple of minutes before they tell them to once again switch it off for landing. And I think that this just shows great compassion and understanding on behalf of the cabin crew. On the ground, the rescue personnel at Los Angeles Airport has had plenty of time to prepare for the arrival of the aircraft. They have gathered all of the emergency equipment that might be needed close to runway 25 left, where the aircraft is going to eventually land, but they didn't spray any fire retardant foam on the runway. And the reason for this, I've actually talked a little bit about in a previous video that you can check out, but the short version is that it has been proven that foaming up a runway prior to an emergency landing actually doesn't really help. It's very hard to judge where exactly an aircraft is going to touch down, and even if you do, it's not going to have much of an effect. And probably the most important reason that we don't do it is because you are using up valuable fire retardant foam that you might have to use if the worst thing would happen and the aircraft would actually catch fire. So it would be very rare for you to ever see the fire department foaming up a runway prior to an emergency arrival almost anywhere in the world nowadays. Now, the weather at Los Angeles Airport as this aircraft is now initiating its approach is absolutely beautiful. The surface wind is 240 degrees at 13 knots, that's almost straight down runway 25 left, and only some few clouds and a temperature of 21 degrees Celsius. After almost 3 hours airborne and with the fuel reduced down to 4,500 kilos, which had been shown to be the optimum fuel load inside of the Airbus A320 to get the center of gravity as aft as possible, the captain, who is now taking over the role as pilot flying, initiates the approach. The reason that the captain had chosen runway 25 left is pretty simple. It's the longest runway around. It's 3,328 meters long. And the crew will need all of that runway because they're now following the procedure called landing with an unsafe landing gear. That procedure indicates to the captain that they need to do a couple of things. But after landing, they're not supposed to use neither the thrust reversers, not the spoilers, or the outer brake of the aircraft. So why wouldn't they be able to do that? Well, the idea is that if you're landing with the nose gear unsafe, there is a possibility that the nose gear might collapse. And if it does so, you don't really want the engines to be running when it does, because there might be parts from the nose gear, apart from the nose, that might be sucked into the engines, and the engines could then potentially catch fire. So the idea is that after landing, you're supposed to shut the engines down. Once you have achieved a safe landing, one of the pilots, the pilot monitoring, is going to shut the engines down. And of course, if you shut the engines down, the thrust reversers are not going to make any difference anyway. But even if you are using the thrust reversers, they are actually causing more forward pressure onto the nose wheel. When it comes to the spoilers, there's probably another reason for this, and that is if you're using the spoilers and the nose gear collapses, there's a possibility that the body of the aircraft might become slightly skewed, twisted. And what you don't want to do is put yourself in a position where you've managed to get the spoilers up on the wings, but because of this skew in the body, they're now not possible to retract, and that will make it harder for the passengers who are evacuating onto the wings to actually do so. And finally, the reason that you don't want to use the outer brake system is very similar. When you start braking, that's also going to put more pressure onto the nose wheel. And here, if you have a very long runway, you can just utilize the aerodynamic braking of the aircraft and the friction braking from the wheels and not use so much braking, thus using less pressure on the nose wheel and potentially keep it from collapsing at all. So this is what the pilots are thinking about as they're now flying the ILS approach into runway 25 left. As the aircraft descends to 1,000 feet, the first officer depressurizes the cabin. This he does in order to make sure that there's no residual pressure inside of the cabin in case they have to immediately evacuate after the aircraft comes to a stop. When they pass 500 feet, he takes up the PA mic and he calls the cabin saying, "Brace, brace, brace." Now the cabin crew has gone through the cabin and instructed all of the passengers on how to do the brace position perfectly. So the passengers will now hold the brace position until the aircraft comes to a full stop. At time 1820 local time, the Airbus A320 touches down at a speed of about 115 knots, well within the touchdown zone on runway 25 left. 5 seconds after the touchdown, the first officer reaches over and depresses both of the fire switches, which causes the engines to shut down. The captain holds the nose of the aircraft up to keep the nose wheel away from the ground as long as possible, but he also knows that he can't do it for so long that the aerodynamic effectiveness of the elevators stop working. So eventually he lowers the nose gear down. Almost immediately the two nose gear tires are deflated and ripped apart. The nose gear wheels are then grinded towards the asphalt down all the way to the wheel axle, and they're creating a lot of sparks and smokes that we could all see on these famous TV pictures as they were doing so. The aircraft eventually comes to a complete stop, bang on the center line of runway 25 left, and initially the crew are waiting because they don't really know whether or not the nose gear is going to collapse. But eventually it becomes clear that the nose gear is holding up, and instead of initiating an evacuation, they call for some external steps to be moved up towards the front left exit, and they start disembarking the passengers through that door. Now, this is something that the crew had also pre-briefed prior to the landing, because you don't really want to evacuate an aircraft unless you absolutely have to. And the reason for that is that during an evacuation, you can be almost sure that some of the passengers are going to hurt themselves. They're going to strain their wrist or maybe break an ankle or something like this. So an evacuation is something that we do as a very last resort. In this incident, none of the passengers or crew were hurt, and the aircraft only sustained some very minor damage to the nose gear, as I explained before. Actually, they replaced part of the nose gear as it was standing there on the runway, and the aircraft was then towed into a hangar where they started to investigate what the reason was for this situation to appear. And that's where they noticed through a boroscopic inspection of the nose gear that the lugs had been ripped off, the upper support of the shock absorber, like I explained earlier, and this led to Airbus changing some of the software in the BSCU, the brake and steering control unit, so that it wouldn't do as many of those pre-landing tests as it had been doing before. They also noticed the incorrect pressure inside of the shock absorber, and they started looking into why that was. That's when they noticed that when the shock absorber was being serviced, it was being done so with the entire weight of the aircraft still resting on it. And it turned out that it was almost impossible to get the right pressure in when that was the case. As a consequence of this, it was mandated that whenever the nose gear shock absorber had to be serviced, it has to be done so with the nose gear properly jacked up so that there were no weight resting on it. Now, it would turn out that this was not going to be the last time that an Airbus A320 landed with the nose gear set 90 degrees perpendicular to the aircraft. There was going to be many, many more of them, but interestingly, for many different reasons. And if you want to know more about that, I've actually done a Mentor Now video on my new channel that I hope that you have subscribed to. You can check it out up here, and I hope that you're all doing absolutely fantastic. If you want to support the work that I do here and on Mentor Now, then consider becoming part of my Patreon crew or get yourself some merchandise. Have an absolutely fantastic day, and I'll see you next time. Bye bye.